Hello, my name is Joseph Susanto from Year 12I, and my tete-a-tete with physics is laser tripwire system. So the physics concepts of this experiment are reflection of light and electric circuits. So what is an electric circuit and what are its applications? An electric circuit is a path for transmitting electric current. An electric circuit includes a device that gives energy to the charged particles constituting the current, such as a battery or generator, devices that use current, such as lamps, electric motors, or computers, and the connecting wires. The first electric circuit was invented by Alessandro Volta in 1800. Examples of which are light bulbs, refrigerators, mobile devices, and vacuums. What is reflection of light and what are its applications? Light is an electromagnetic wave. Reflection occurs when a light ray bounces off an object. If the surface is smooth and shiny, like glass, water, or polished metal, the light will reflect at the same angle as it hits the surface. This is called specular reflection. The angle of the wave approaching the boundary is called the angle of incidence, and the angle of the wave leaving the boundary is called the angle of reflection. Ancient Greek mathematician Euclid was first to experiment on reflection of light in 300 BC. Examples of which are Carwing mirrors, microscope, telescopes, optical fibers for internet, and our vision in general. What are the materials used for my experiment? 4000 ohm resistor, NPN transistor, LED light bulb, buzzer, light dependent resistor, 9 volt battery, battery cap, small mirror, cardboard box, and laser. What are the parts of my experiment? First, we have a light emitting diode, a semiconductor device that emits light when an electric current is passed through it. Buzzer, an electric device that makes a buzzing sound when a current is passed through it. Battery, a single unit device which converts chemical energy into electric energy. It provides the electricity for our circuit. Wire, a type of conductor, which is a material that conducts electricity. Transistor, a semiconductor device with 3 parts, collector, base, and emitter. It is similar to an electronic switch. When on, current can flow through it from the collector to the emitter. When it's off, no current can flow. It is acting like the brain of my circuit. Resistor, an electrical component that limits or regulates the flow of electrical current in a circuit. Light-emitting diodes and transistors are sensitive to the amount of current and need specific amounts to function properly, which is why I'm using the resistor. Light-dependent resistor, LDR. The resistance of an LDR depends on the light intensity. As the light intensity increases, its resistance decreases, and vice versa. My electric circuit. Light exposure and resistance of LDR are inversely proportional. Thus, when the LDR is exposed to light, its resistance will fall. Thus, when a laser hits the LDR, resistance will decrease and the current will be able to pass through. The voltage at the base of the transistor will increase, and once the voltage increases above the threshold, LED and the buzzer will turn on, emitting light and loud noise. In contrast, when an object blocks the laser which is walking through the doorway, the laser will not hit the LDR, and thus the LDR will not be exposed to light. Thus, the resistance will be very high, and current will not be able to pass through. Then, the voltage at the base of the transistor will decrease, and the LED and buzzer will not have enough voltage to turn on. This is me connecting the circuit. This is the image of my final circuit. Infrastructure. My project is a mini replica of laser trapwire systems used in museums, restricted gates, and banks. Mirrors are set up so that the laser trap wire can cover a wider area. The ray of light from the laser pointer keeps reflecting off the mirrors until it hits the light-dependent resistor. This is me building the infrastructure. This is the image of my final product when it's off. This is the final product when it's on. Thank you for watching.